All right, let's get going. Welcome back, everybody. I'm Steve Hansen. I'm the Director of User Education here at LabKey, and today we're going to continue our agenda into day 2 here. Today we're going to talk about assays and experimental data and how to, get it into the server the right way. And then the other main topic is data structures. So those are kind of the two main topics. I'm going to throw in a little cameo in the middle there. We're going to take a quick look at samples in Sample Manager. I know it's not really LabKey Server, but it is, and I want to sort of emphasize that Sample Manager it's available as it's part of every premium edition of LabKey. It's also available on its own, and it's based on LabKey Server. And it'd be kind of cool to see the relationship between them. And now that you're an admin, you're going to have to know how to serve up Sample Manager to somebody who wants it. Again, the ground rules are kind of the same. Use the Q&A feature. I'll try to answer them as best we can. If I can't answer it, we do have these recorded and written down, and we'll follow up in email if you stump me. Actually, before we even get started, though, there was something last night I was like, oh my God, I didn't show auditing. And auditing is so awesome in LabKey. I just wanted to quickly go and look at the audit log as part of it to finish out security. And so the audit log, it'd be kind of cool. Remember, we did a bunch of stuff on the server yesterday. How much of that got captured? Well, the answer is everything gets captured. So auditing is very intense in LabKey, and it's just everything gets captured. So I'm going to go to this is something just every admin needs to know. We're going to go to the gear, we're going to go to site area, and then the admin console. Notice this is kind of the dashboard for site admins. This is there's so many links here, I couldn't even get through it. But there's a configuration area, there's a management and a diagnostics area. Let's just look at this audit log link. So the audit log is a giant table. It's got hundreds of thousands of rows in it for a mature server. And every time anything happens on the server, basically it gets recorded in the audit log. And it's really quite detailed. And in fact, it's such a big table that it's divided up into these different facets. And that's what this dropdown tells you, it lets you kind of change the faceting on this table. And first off, it's showing me all of the assay and experimental events. And basically every event is dated and it has a created by, which is the person who did it. So what's been happening? Well, last night, Steve Hansen was basically prepping his assay demo. And you can see, what did he do? He's playing with the QC states, he's importing data, he's loading runs. I'm working at 550. And then so that's what happened last night. Yesterday, this is what we all did together. We did some QA stuff, etc. So that's just the assays. Let's kind of look at some other stuff. We did some work with lists. Let's look at what happened with lists yesterday. Sure enough, remember we made that cell culture list and we loaded it with data and we played around with it. All that stuff got recorded. And in fact, look at this, an existing list. This is interesting. An existing list record was modified. Well, can I get any more detail on that? Yeah, I can. And here's how to do it. There's a grid view menu here, and you can actually add columns to learn more. If you want to know more, let's go add some columns. And sure enough, you can see there are these cool columns to add: old record value, new record value. Let's see, what do I get there? Cool. Now I can see that an existing list record was modified. Well, what was modified? Well, the old record was culture day 1, pH 1. The new record is culture day 1, pH 7. So I hope that's kind of all I wanted to show you. I hope this really makes it vivid for you how detailed the audit log is. Basically everything is captured. 46,000 rows in just this facet. In any case, that's all I really wanted to show on that. And let's go on to our agenda. The real agenda today is assays and experiments. So, LabKey assays. This is really the most complex part of the server. This is a framework for importing and dealing with and managing assay data, experimental data. I mean, why wouldn't it be the most complex and built out part of the server? We do scientific research data. So naturally, the module that handles research data is pretty built out. So why use it? Well, it's a framework designed to capture your experiments and assay data. It provides sophisticated handling for those novel instrument file formats. It's one of the great things about LabKey. Now, I don't know if you've ever dealt with instrument files. Now, when I say instrument file, I mean the kind of file that a scientific instrument will output. Like, I don't know, Thermo Fisher ELISA plate reader, or incubation plate reader, or whatever. There's a million of these, or a liquid handler, or whatever. All these different instruments, a proteomics instrument. Oftentimes they'll be able to output their result file. For whatever reason, the companies that make these instruments are sadistic about the file formats. They love to make novel file formats that are really hard to import and deal with. Well, luckily you have LabKey to help you with that. They don't seem to want to output a simple database shaped table. They always have to offset the table and put headers in and turn it upside down and make it all crazy. Well, luckily you got LabKey Assay Framework, which has all kinds of tools for handling those instrument file formats. Sometimes we just know the file format, we can handle it. And if not, you can do a scripting to do your own parsing of the file formats. And if you don't know how to script, you can often mitigate it with just some manual stuff. In any case, so that's a huge advantage of working with LabKey assays. We have a built-in quality control system for your instrument data. We also, by design, link the assay, the LabKey data, the imported LabKey data, to the original instrument file, so you get really nice data provenance. We also, in general, this is universally true, LabKey enforces data standards and does validation on data import. So you end up with clean data. It's not messy data. We also offer integration with samples, integration with clinical data. And I've got a little duplicate here. And handling for instrument file formats. Anyways, I see some questions here. Is there anything? It's a few questions on auditing. Let me just handle these. One question is, the auditing is awesome. Being so extensive, does that show the server, slow the server down, especially when you have hundreds of users? I don't really think so. I haven't heard about it. LabKey performs well. I mean, there's a lot more going on than just the audit log when you have hundreds of users. I think actually it's more things like, honestly, if anything's slow in LabKey when you have lots of users is when you have lots of users looking at the same thing. If you've got hundreds of users and they're all working on that one table, that can slow things down. And the table is really big. There's where slow is. Auditing, I don't think it's a problem. Another question is, which audit log would you find changes to specific participant sample records, such as date of collection? There's a data sets part of the audit log that I'd look at. There's also a sample part of the audit log. I'll try to remember that. And when we come back, when we actually look at samples today, I'll take a look at it again. And tomorrow we're going to look at data sets and clinical stuff. And that's another place I'll try to remember to go back there. Great. In any case, so back to assays. Anyway, so this is kind of some of the highlights, great reasons to use assays in LabKey. Now, the assay framework is complex. So let's kind of back up and just sort of get a lay of the land here. First of all, data is stored in something called an assay design in LabKey. And an assay design is one of the big 5 data structures. We're going to do data structures next. But just to put that in context, assay designs are one of the big 5. They're a table type. There are 2 kinds of assay designs. There's actually a dozen kinds of assay designs, but there's 2 kind of phyla, kingdoms. There's specialty and standard. And specialty assay designs are pre-built structures, pre-built tables that are instrument specific. They're designed with a specific instrument in mind, whether it's NAB or ELISA or Luminex or some others. They are prepared for weird file format. They have a file format in mind already. They're ready to parse that file format, like the Luminex file format. If you've ever seen it, it looks like an Excel file, but there's a bunch of header rows to start out, and then the table's offset down the page. Well, that's the Luminex instrument tends to put out that kind of style. The Luminex assay design in LabKey knows about that, and it's just ready to handle it. So there's specialty assays, and then there's standard assays. And standard assays are instrument agnostic. They're just kind of generic. They don't have an instrument in mind. They're just ready to take on some Excel file or some TSV file. So we're not really going to do much with specialty. We're just going to look at standard. It's plenty to deal with. It's enough to know right now. But let's just, before we go to the main course, let's take a look at specialty assays and just get a sense of how cool they are. So specialty assays, there's a whole bunch of them, but there's basically 3 kinds. There's plate-based specialty assays like ELISA and ELISpot and Luminex. And then there's a proteomics module that can handle proteomics data like MAGE files and then and things like that. And then there's a flow cytometry module as well, which can handle FlowJo files. Each one of these specialty assays kind of has 2 great features: their ability to handle the file format on import, and a bunch of domain-specific reports and views, which are one of the best things in LabKey. Like here's an example of the NAB plate designer, just a screenshot of it. You can design these plates for your NAB assays and import with these kind of well maps in mind. Really cool. By the way, we're really improving this year, and we're going to really improve our plate support right now in the next couple of months. And here's another cool view from the flow specialty assay. This is a view of a report about your flow gates that you can see in LabKey. And then the proteomics data. By the way, the proteomics module is the oldest module in LabKey. It's has the most storied history, so it's just full of stuff. There's so many highlights to it. So here's the run summary from this proteomics experiment. This is a live demo. You can see this yourself. And basically, here's the table of the peptides and the proteins that we're studying here in this MS2 experiment. Let's just pick one of them. Like let's look at this peptide. Look, you get this great MS2 mass charge graph. There's so much to this. There's this whole dashboard on the left where you can refine the view. This is actually also drag and droppable. it's zoomable. So if you wanted to kind of zoom in on these peaks, you can. Or if you wanted to zoom in just on this peak, these two peaks, you can, that kind of thing. There's just so much to play with here. Then there's also, this is all in the same thing. There are these pie charts that show you different things about the proteins. And then, did I look at this? Oh, we saw that already. Anyways, that's just this. There's way more to see. I can't even show it all. It just kind of keeps going here. So that's just a little, again, just to give you sort of a teaser for some of the cool stuff inside of specialty assays. But let's leave those aside and let's go look at standard assays in detail. So standard assays, they just handle generic assay data. They're perfect for your importing Excel files or TSV files, anything that's kind of tabular. The drawbacks are there's no special reports or views. You have to build your own reports, your own views. And there's no special handling for at least no automatic special handling for special file formats. You're either going to have to do some manual work or some coding to make those work. But on the other hand, the coding's not super hard, if you know how to walk a table in R or something like that, you'll be fine. So all specialty assays, they're just a table type, but they're a pretty complex table type. There are 3 kinds of fields to an assay design. They're kind of in this, like I think of it as a chandelier of fields. At the base of the bottom of the chandelier, there's the results data. And then there's 2 kind of super levels above those, which are for kind of global properties. There's run properties, run fields, and those are more global fields. Then these are the run fields are where you can put your experiment parameters or variables or maybe any kind of grouping concept you want to put. You can put them in runs as a run field. And then there's even another level, higher level of grouping called the batch fields. And these are even more global. I mean, you can sort of put whatever you want there. People often will put, say, project or run group or something like that there. And now this is a pretty hard concept to get, I think, just from a slide. I think I might want to, let's just go over and look at what this really means in practice. I'm going to go over to an assay which is already all imported and complete. Let's go over to this. Here's a whole, by the way, here's a whole bunch of assay designs, the whole list of them. There's CBC, that means complete blood count. That's an assay design I built for demoing. There's this cell culture assay design. Here's a drinking water assay design. I got one of those drinking water test strips where they has all these different little colored squares on it, and you can read your copper levels and your lead levels in your water, things like that. But I wanted to look at, so there's all these different assay designs. Let's look at pH. There are 3 views of the data that are in this assay. There's a batch view. These are all the batch properties. There's only 4 batches. So they're very global properties. There's a runs view. This is the mid-level view. There's 6 runs of this assay. And a run, also another way to think about a run property is it's like one cycle of the experiment. And then there's the results view. This is the bottom of this is the base. This is the bottom of the chandelier. There's 26 runs of this experiment, or 26 results. I'm sorry, 26 results from this experiment. And so let's just kind of see that again. There's at the top of the chandelier, there's the batches. At the mid-level of the chandelier, there's the runs. And then at the bottom of the chandelier, there's the results. And one thing that is also really great about this is that you can always pull down the global properties down to the results level. So you can do that again through the grid customizer. Let's go get some run properties. Here are the run properties. Let's go grab one of them and say, I don't really have very good run properties. Let's do QC. There's some QC stuff there. So great, now I know these are now global properties at this QC flags. It's like global properties added to the results fields. So anyways, those are the 3 kinds of fields you get in an assay design. You're going to keep running into that. Well, let's, some other stuff here just before we actually go and make an assay design. Let's just kind of look around what this assay design feels like a little bit. First of all, again, it's just a table, just a grid, but you can do all the kind of classic universal stuff. Let me save this, by the way. You can sort of do all the classic universal stuff you can do with any table in LabKey. There's this button bar. You can do things like grid customization, add different columns, remove different columns, things like that. You can sort stuff. So if you want to sort stuff by, say, you probably don't want to do this, but I'm going to sort the pH column from low to high. I can do that. Or we probably want to do more, something like sort the culture day from low to high. But let's clear all these. Let's clear these out. You can also do things like build visualizations on these tables. You know, like let's do a line chart where culture is the x-axis, culture day is the x-axis, sample ID is the series, and pH is the y-axis. This will give us sort of a chart of everything, all the different pH levels throughout the course of the week. So things like that. So, you know, there's nothing really special about this table in that respect. It's just like a table with all the tooling that you have on it. One thing, though, that is also notable about assays is they link, or they can be made to link to another table type called the samples. Now, we're going to get into that later, but just take a look at this column right here. There's a sample ID on this table. And what the sample ID is, it's saying, well, this is the sample that we ran the experiment on. And if you want to know more about that sample, go click this link. So we put a blood sample in here for some reason. Let's go look at the blood sample. Well, there's a whole bunch of stuff to know about this blood sample. Like, it's in these files. It has these histories. This is it has these kind of experiment histories, which we can get in these using these flow charts here, etc. There's a bunch of other metadata about these samples, etc. Like the tube type is heparin, or the preservative element is heparin. It's, Susan H was the receiving operator. So you can already start to get a sense of kind of how broadly integrated this experiment data is. We know the results of an experiment over on that assay design. And we also know a bunch about the sample. Just by one link, we saw all this metadata about the sample. And again, we'll get into that when we do our mini unit on sample management. So anyway, so that's kind of assay design stuff. I see a couple of questions here. Let's see if there's anything. Nothing new there, so I'll keep going here. So let's actually make an assay design. Like, how do you get, like, what's the thinking that you want to engage in when you create an assay design, when you try to import your assay data into LabKey? Let's sort of go through that. And I'm going to use the same data I did yesterday, the cell culture design, the cell culture Excel file. Yesterday, I put it in a list. And I said at the time, this is probably not the best and highest use of this data. It should properly be put in an assay design. Well, now I'm going to put it in that assay design. So first of all, let's go look at that. Let's go look at that Excel file. It's right here. And Excel always, okay, that opened pretty fast. Okay, so again, it's a 7-day experiment where we measure the pH levels and the sugar levels and the cell viability on these different samples. Now, these samples, notice these sample IDs are, I have 7 different sample IDs. Those are like draws. Each one of those, the way to interpret those is those are each different little pipette draws off of the incubator. And so there's probably a missing piece here, which is, well, don't you want to record the biobag, the incubator, as a one thing? Like, it's not changing. Like, there's like some expression or some biobag which has one ID. Don't we want to capture that? Well, we are going to capture that. We're going to capture it in a run field. We're going to capture a whole bunch of stuff in the run fields. Stuff that isn't really here in the, this is the results fields. Sample ID, culture day, pH, sugar, those are all going to be result fields in our assay. But a lot of times there's a lot of metadata that isn't in the result field. It's like the experiment design, the experiment parameters, the variables, sort of the precursor stuff. Those are often best to put in the run fields. Sometimes they go in the result fields, but in my case, I'm going to put them in the run field. So anyway, so that's the Excel file. Let's get it into an assay design. So let's go back to our main project. And let's go into admin mode. And let's actually add a new tab. I just want to add a new tab to sort of get some more real estate here. And we're going to call this the assay data tab. And this cell culture tab is a little confusing, the name of it. So I'm going to rename it and just call it the list tab. And now we'll use these tabs later, but for now, let's go to the assay area. I'm going to gear manage assays. This is where I can make a new assay design. Now, there's already an assay here called pH. We'll get to that later. Ignore that for now. I'm going to create a new assay design. And I'm just going to click this new assay design button. Here it is. This is me entering the designer for standard assay. Remember specialty assays, they're right here. If I want to make a specialty assay, I could. Which one do I want? You know, Luminex, ELISA. No, I don't want any of those. I want to make a brand new standard assay. And here's an important dropdown. I'll get back to it. Assay location, current folder or shared folder. What does that mean? Well, it means a lot. This is actually a really important dropdown, and where you put the assay design really matters. I'm going to just do the default, but we'll get back to what this dropdown means in a minute. Okay, so here's the assay designer. Notice how it's more complex than the list designer. This is a table designer, but there's a lot to it. Lots of properties up here. There's like a QA states. There's runs and transform scripts and all this stuff. We're just going to ignore this for now, except for the name. We need a name. We're going to call this the cell culture assay. And well, okay, we'll give it a description. An assay to measure pH, sugar, and cell viability in a cell culture. Now, there are those 3 fields, 3 field sets: batch, run, and results. There they are. We just need to sort of open them and start filling them out. Now, notice there's some default fields here. These are a little bit old. These are kind of an artifact of features of the past in a way, and I don't want to use them. I just don't want these fields around. They're sort of a pain. And so there's these two batch fields here, and I don't want them. I'm going to get rid of them. There's also 4 run fields here. I don't want these. Not now. I mean, there's a specimen ID. I don't really want that. There's participant and visit ID are good to have here, but let's do those. Let's worry about those later. And then there's a date field. We should probably have a run date field, but let's just get down to 0. So now we have no fields. We're going to totally do this custom. Let's do it that way. Now I'm going to get my results fields from my Excel file. Let's do that like we did last time. I'm going to just go point at the Excel file and say, you figure it out, LabKey. And I'm going to do similar stuff that I do with the list. We don't have any, this LabKey knows that the sample ID should be a lookup to the samples. I don't really have any samples, so I'm going to make this a text field. And culture day should be an integer, pH should be a decimal, sugar should be a decimal, and cell viability should also be a decimal. I'm going to change that. And also I know that pH is better if you put that label there. And I think that'll do. Oh, it's not quite enough. Let's also add some run fields. There's some metadata that we want to capture. And let's put them in as run fields, as kind of global properties of the experiment. One thing I want to capture is, say, media type. My cell culture experiment is going to use different kinds of media. There's like media A, B, C, whatever. I want to be able to record that. It's like an experimental parameter, experimental input. And I could capture that as a text field, but let's do something more fun. I'm going to use this cool new feature we have called text choice. It'll be like a dropdown. And I'm going to say I have 3 medias that I use in my lab. There's media A, media B, and media C. And then let's also, what else are some fun ideas to capture here? Let's capture, oh, the other thing that we thought we wanted to capture was something like the biobag ID. This is like the big bag where we're doing the, let's call it incubator ID. So it's like the name of the bag. And we'll just make that a text field for now. And let's call it our assay design. Let's save it. Great. We've now got a cell culture assay. There's nothing in it. Let's put it on this. Let's put it on here. We'll do. Oh, not really set. Look. Okay, we're learning a lot here. I want to put an assay results tab panel up here, but I don't have it. Well, what do you do when you want to add a web part and you don't see it? You go to the modules and you enable a module. That's what you do. So let's back up. Let's go add a module. I bet I need to add the assay module, because that's going to include a bunch of UI and web parts for assays. Let's try again. Sure enough, assay batches, assay list, assay results, assay runs. Let's add the assay results table. All right, and we'll add the cell culture assay. Great. All right, I've got some UI to play with my assays now. Let's actually import some stuff. I'm going to click import data and import data into this assay. So notice it gives me my run fields and a way to import my file. And here are the run fields we just added. There's media type. We'll say this is media A. We used media A in this experiment. And the incubator, oh, let's try it again. And for the incubator, we'll say we used, incubator 001. And here's where I can put my result data. I wish this, by the way, it says run data here. I really wish it said result data. I think it's just an old mistake. We could copy and paste the Excel file like this. Oops. Could do that. And in fact, this is just the kind of move people do when they have some weird file format, which maybe has a bunch of headers and then the table's offset. They'll copy and paste the offset table right into here. But let's not. Let's kind of not do that. Let's actually go point at the file. So I'm going to go just point at that Excel file. And hopefully this will work. Awesome. I just imported my first run of cell culture assay. And here are the run fields. So I'm looking at the run table right now. The run fields. We used media A, we used incubator 1, blah, blah, blah. Let's take a look at the results. There they are. There's my Excel file. And notice LabKey thoughtfully put media and incubator fields right in the results already. It just sort of did the join for me. That's kind of nice. Well, great. Let's keep going. Well, let me see. Am I missing something? Great. No, let's keep going. Let's go. Just kind of, let's do another run. Let's import another run of data. And this time, let's say we used media B. And let's say we used incubator 2. And now let's go grab this run. There's another Excel file. Same experiment, just different run of it. Well, great. We've got 2 runs now. Let's look at the results. We've got 14 results with different media. And I think I hope you're sort of starting to see kind of the advantages of the assay framework. You can, what I'm getting here is I have a way to have experimental results, but analyze them based on metadata, like what media I used, what incubator I used, what parameters I used. So this is one of the great advantages of the assay framework. Let's, I could create a report on this and whatnot, but let's hold off on that. And instead, I wanted to show you some other really interesting things about the assay framework. This is one of the things that the assay framework does is it is aware and it imports in the background the files that I used, the Excel files. So the Excel files are actually back here. You just don't see them. Well, let's go see them. This is one of the great advantages of LabKey, and it's not often appreciated. So in fact, let's add a files tab. Oh wait, I already have a files tab. It's right here. Notice there's a new directory. I didn't create a directory called assay data. LabKey did. And by the way, let's rename this tape. Let's rename this file. This tab is files. And what's in this directory? Well, lo and behold, cell culture 1 and cell culture 2, those Excel files we imported. LabKey just imported those. Those are the Excel files. And notice there's a link here called usages. What this link is it's a link to the imported data. So notice I've got a really nice two-faced view of the data with a great data provenance story here. I started the day with an Excel file. Now I have an Excel file online linked to its database incarnation in LabKey. It's great. That's really, really nice. I've got the date and time it was imported. I've got myself a data provenance story. So that's great. Not often, I think, appreciated how great that is. Another thing, well, we'll wait on that. Oh, here's another thing. You can actually also, there's lots of ways to import data in LabKey into the assay world. And you can also start your data imports from the file area itself. So suppose you wanted to do this kind of thing. You've got, say, more cell culture stuff you want to import. Say you got these two other, this cell culture 3 and cell culture 4 that you want to import. Now these are online, right? They're already up online because I dragged and dropped them there. They don't have database incarnations yet. They haven't really been imported yet. But let's import them. So what you can do is you can actually now say, I want to import these two files together. And I'm going to, what you do is select them and click import data. And there's a little import data button right here. And now LabKey's saying, well, where do you want to import these? I can see two things, two assay designs you might want to use. You have a cell culture assay and a pH assay. Which one do you want? I want the cell culture assay. You already selected it for me. Okay, great. And notice it's giving me my a place to put my run properties. Are you using Media B? Yeah, I'll say yes. Are you using Incubator 2? No, I'm using Incubator 3. And okay, so there goes my first run. This is cell culture 3, so you can see the file that's queued up. Great. Now let's queue up the second file. I mean, cell culture 4. What media did you use? We'll say I used media C. And any other comments here, you know, sort of high temp in a lab. So maybe there's a QC worry there. Great. Now I just have got 4 runs of assay data imported. The files look like this. They're 4 files linked to 4 database tables or database incarnations. And here is our assay data tab. We got 28 rows of data with different groupings possible for the analysis. Awesome. Some other nice things about LabKey and assay data. There's lots of enforcement around file name in LabKey. So if you try, then this is a good thing. If you try to import another file with the same name, LabKey will stop you. It'll try to stop you. And you can see that right here. Here I have a cell culture 1 file right here I haven't used. Let's try to import it into the assay. I'm going to select it and do this thing where I say, use the cell culture assay. Well, do I want to do this? I kind of expected it to bulk. Well, okay, I'll try. Maybe I'm going to screw this up. Oh, well, it took it. I didn't want it to take it. That was kind of a mistake. I didn't want that. Let me get rid of it. Anyway, it was supposed to error out. It was supposed to say, don't do that. You can't do that. But it did. I'm not sure why. But anyways, the idea is it's supposed to be that there's file name enforcement for those kind of things, because I'd already had a cell culture 1. And another thing I think that's really, sorry, failed demo. Another thing I think that's really important in LabKey assays is, by default, the data is not editable. So suppose I am looking at my assay results and I'm like, there's a mistake here. Like that should be 1, not 7. I want to change it. Well, there's actually no edit button provided. There's just, the system by default doesn't want you to edit it. Why? Because assay files are considered canonical. They're considered canonical because they were generated by an instrument, and you can't just go and change your results because you don't like them. That's the idea. And it's a nice idea. It's a good idea in LabKey. So if you want to change this value, you have to do one of two things. You have to either re-import the run, which we provide for. What you do is you say, suppose there's a mistake in cell culture 1 and you have revised file to import. What you can do is select it and go through this re-import run system. So go to re-import run, and it'll redo it for you. And it'll record it all. It'll like audit the change. You're like, oh, well, there was a mistaken file that got re-imported, and here's the changes. So that's kind of cool. That's a great little, again, data provenance and auditing system set up for you. Or you can do it on the cheap and go into your assay design and turn on editing. So I'm going to go back to my assay design and just turn on editing. I'm going to say, yeah, I want to be able to edit my runs and edit my results just in place. Now this will all be audited. Now I can see an edit button. So now I have an edit button here, and I can say, oh, that 7 really should have been 7.1. And I can do that. But you have to be intentional. And your administrator, needs to enable that, make that happen. So another thing, we've seen that files and designs are linked. Okay, here is a concept I want to get across. I'm going to try to return to this concept every day. And that's the idea of a folder scope. This is something that assay designs take advantage of. Depending on where you put the assay design will have narrower or broader scope across the server. If you put the assay design in a subfolder, it'll just exist in the subfolder. On the other hand, if you put an assay design in the project, it will be available, the assay design will be available in the project and in all of the subfolders of that project. So you'll have a single assay design, a single experimental standard that you can apply to all the folders. That's a good thing. And third, if you put the assay design in the shared project, which we haven't talked about, it will be available throughout the entire server, in every folder of the server. That's why when I go to my assay list, I see 2 assays. There's this cell culture assay, we just made that one. But then there's this pH assay, and notice it says an assay in the shared folder. There's another assay out there in the shared folder called pH, and it's just it's everywhere. So that's just a nice thing to keep in mind. I mean, what does this pH assay look like? Well, there's nothing in it here. But if we go over to the shared folder, now I'm in the shared folder. Here it is too. There's the pH assay all over again. Let's look at it here. Well, there's nothing here. Well, what is that? Why? Was there no data in it? No, there's data in this assay, but there's no data in the shared folder. And there's no data in our folder. There's data somewhere else. And you can actually get a global view of all the data in this assay if you use this piece of the UI called the folder filter. The folder filter tells you which scope of display you want. Do you want to just display the data in the current folder? Or do you want to display, say, all the data in all the folders? What if I do that? Oh, well, there's a bunch of assays. There's a bunch of rows of data in this assay. They're just kind of scattered throughout the server. And here's a roll-up view of it all. In fact, let's add a column to see where did this data come from. So let's add the folder column. Okay. A lot of it's in the assays folder, and then there's this mouse colony folder. So this is sort of a roll. This is like assay data that was scattered around, and we just collected it all here to look at it. So the basic pattern here is assay designs can be shared over many folders and be common, a common resource, a common shape, a common standard. Data isn't shared. Data is folder by folder and can be sprinkled and scattered throughout the server, but can participate in that shared data standard. That's what you're seeing here. You're seeing 7 rows of assay data, which are scattered around the server, but which all conform to one data standard, that assay design. This is a great feature in LabKey. People should utilize it when they do their architecture. It works for assay designs. It works for samples as well. It doesn't work for everything, but for those 2 things, it does. Got some Q&A. Let's see what we got here. Someone asks, I notice you don't use spaces in a lot of your fields. Yeah, are spaces accepted, or do you have to format names that don't have spaces in them? That's a great question. It's in fact true. I tend to avoid spaces. Honestly, they are allowed, but I think it tends to make things ugly in LabKey. If you use spaces in fields, if you plan on doing SQL queries later, it makes the SQL queries ugly. And I just don't like to do it that way. You can always make the label have a space in it. And so I just prefer to have I prefer to avoid spaces and then introduce them as labels. Also, similarly with folder and project names, it makes the URLs really ugly to have spaces, because spaces are replaced by like #02 or something. And so I really like to use underscores when I make folder names, because just the URLs become a lot more readable. That's a great question. Abilash, or excuse me, another user says, sorry about that. What if the user forgets to mention the values in run field and accidentally includes the values in the Excel and directly imports them to results? Will the values be captured in the run fields automatically? The answer is no. There is a way to actually capture run fields through an Excel file. I won't go through this, but it's really cool. Let's go to an Excel file. There's actually a way to set up automated assay imports through the file watching system. We're not really, maybe I'll have time to look at file watchers tomorrow, but just to let you know, there is a automated import system called file watching, where you can basically drag and drop files into the system, and LabKey will watch for them. When it sees a new file, it'll just import it. You don't have to do anything. When you get that all set up, you can do this. What you can do is you can encode your assays like this. If you make 2 sheets and you name one of them results, and then you name the other one runs, and then you put the run fields in here, it'll work. It's really cool. So that's a way to have automated assay import and capture runs and assays just without thinking about it. And you can even do batches as well. Anyways, that's just, you'll have to read the docs to really get the full meal deal, but it's available. So we got some other and another question is, how do I create shared projects? Actually, you actually don't create shared projects. You just get one. You get one project by automatically called shared, and that's where you have to do stuff. You can't make another shared project. Great. Okay, let's see. We're already getting at time's already clicking away here. So quickly, what else did I want to say a bit? Yeah, let's just quickly look at QC states in LabKey. There's another great built-in feature in LabKey is the ability to layer on QC states. So let's go to our assay design that we're developing, and let's put some QC states on it. So we're going to go back to edit the design, and we're going to turn on QC states. There's a little button here that says turn it on. Great. And you get, by the way, the Q states are, you go to they're run by run. So you set QC states on a run. Notice there's now a QC state area. Now QC states are like quality control states. They're like, you can build a little workflow of quality control by defining different states that the data can be in. And so let's go and first of all, make some QC states. And here's how this is the area where you can just add different properties. You can say there's a passed state, there's a rejected state, and then there's a not yet reviewed state. And let's also set up a default state so that it's not yet reviewed. Anytime anybody imports data, it's going to start out as not yet reviewed. So we've got sort of our little workflow defined here. There's not yet reviewed, which is like every data incoming will just be that. And then it's either going to be passed or rejected by some review board or something. And great, now we can do that. We can actually set these manually. Let's say we've reviewed 3 of these runs and we've decided they've passed review. Great. We'll select them and say, set these to be passed. Oops, I mean passed. And they look good. Nothing weird about that data. Now let's take that last one and say, no, it's failed QC for some reason. And let's say it was rejected, and let's say the incubator was contaminated. Great. Now we've got these nice QC states layered into the runs, and you can see those in the results as well. So actually I need to add them to the results. I went to the results table, and now I got to kind of pull down that run property I just made, and it's called it's a run property, so I got to open that run node. It's called QC flag. Well, great. Now I've got another grouping mechanism for doing my analysis. I can do things like filter out these rejected states, rejected runs before I do an analysis. Okay, so that's that. I just want to make sure you know about that. Let's skip QC trend reports, but basically there's a built-in report where you can look for peaks or valleys or unexpected. You can sort of set a range and say, I expect my results to sort of be in this range of standard deviation. And if it comes out of that, I want a report that tells me. That's a built-in report for QC for assays, just so you know it's there. And then I think finally, I just want to mention another great feature of the assay framework, which is transform scripts. These are scripts that you can attach to an assay design. You can write them in Python or R. And basically what the scripts will do is they will examine the file that you import, and you can do whatever you want to that file. You can change the file, you can make calculated values, you can parse the file, say it's a weird format. You can parse it and tell LabKey how to import it. And I have a little tiny little demo of such a script over here. And basically what this transform script does is it takes data like this, a specimen ID, a date, and a score. And you pass that data to this assay design, and the script grabs that file and says, I'm going to do something with it. And then it will actually, what this script does is it looks for range, it does a range check. And it says, if the value is out of range 0 to 1, it'll write a little message that says out of range into that mess. That's all controlled by that script. And the script itself is really pretty simple. I believe it's is it this guy? Let's take a look at it. Yeah, that's the script right there. And oh no, that's a different one. This is a different script. But anyways, you can see it's pretty small. This is all, by the way, total boilerplate. We basically give you that. And this is the only real part of the script that's any meaning is right here. This is the user part of the script. But in any case, that's the kind of the idea behind those transform scripts. People do it all the time when they have weird formats and they want to sort of automate the input. Another thing we can do with assays is you can link their results, send them over to a study, another folder. We'll do that tomorrow. So there's a lot today. I know assays can be complex. They are complex. There's a lot to them. And I just kind of leave this slide to you as exercise to the user to kind of like look at these terms and ask yourself, do I know what those terms mean? You know, what's an assay design? What's the difference between a standard and a specialty assay? What's the difference between a batch and a run and a result field? Kind of build yourself explanations for these things, and see if you are happy with them. Also, assay scope and folder filter. Like, do you understand these concepts? This took me a while to understand these. I'm gonna give you another chance to understand this tomorrow as well. Anyways, that's my presentation on assays. If you have questions, put them in the chat. And let's have a little interlude and quickly look at samples and sample manager really quickly. I just want to do 5 minutes, 10 minutes, and we'll take a break. This is sample manager. Like, the whole world of samples has really been under a revolution at LabKey in the last 4 years. We've done all kinds of work around samples. We've really built a product around samples called Sample Manager. And it's a great product. It comes with every premium edition of LabKey Server. If you have a premium edition, you already have access to this product. And so let's just kind of take a look at it briefly. We have a good example right here. No, okay, first of all, this is the LabKey server, right? Doesn't, like, great. You've seen this before, right? Well, you haven't seen this yet. Here's some samples, some like blood, DNA, stuff like that. Here's some assays. You've seen those. These are assay designs. These are all the stuff. This is a pretty rich folder. There's a lot in this folder. There's some data classes. We haven't talked about those. There's a bunch of stuff in here. But this folder actually has another UI that I can utilize. This is the old LabKey Server UI, but I'm going to change the UI. I'm going to morph it into Sample Manager UI, which is really, really slick. And you do that from this little menu, this little 4-square menu. This means switch the UI. So I'm going to do that, and I can see there's a Sample Manager UI, and I just want to, oh, sorry, I did it wrong. I want to go to Sample Manager UI. All right. Now, the data is the same. I'm in the same place, but the UI is different. And you can see it's a lot slicker. It's a lot more colorful. It's a lot more fun. Here's those blood samples. Here's the grid of blood samples. Same kind of grid. It's sortable. It's filterable. It has a button bar on top of it with tooling. Same stuff, just a little slicker, a little more fun, a little more dynamic. You can, the search, just everything's a little slicker. Like you can do, the search itself is kind of cool. So here's a one row of blood samples, one row of one blood sample called blood 1500. And this is just a blood table. I mean, sorry, this is just a sample table. It's another one of the big five data structures. And the thing about samples, though, there's superpowers to every data structure. And for the real superpower of samples is that they capture relationships between samples. So let's take a look at the details for this one blood vial. This is a vial of blood called blood 1500. One of the things that is true about it is that it doesn't exist anymore. It was discarded in August. The data is still around, but it's gone. What is it? What's the history of this blood vial? Where did it go? What is it all about? Well, we know that it came from this subject, 1511. So that's one of the relationships that we know. There was a human subject, a female Kashmiri speaker, who gave us that blood vial. We also know that it had something to do with study 4. That's another relationship. Study 4, whatever the heck that is, that blood vial is part of that study. Now you can actually see those relationships in a graphical form off this tab, off this view. What this graph is telling me is there's a blood vial called 1500, and it came from study 4. It came from that Kashmiri speaking female. And later on, it turned into a bunch of stuff. It got processed into 3 PBMC vials. And those in turn got processed into DNA vials. So we already know, we started getting a sense of like what those relationships are like in LabKey. And this is one of the coolest things about samples, is that you capture this whole workflow or this whole history. Another thing that is true about LabKey samples is that they're tightly joined to assays. I mean, you might even think of what is it? How does a data scientist, what's the data scientist's definition of an assay? Oh, an experiment. Oh, that's the thing that turns your samples into data, right? So samples and assays are really tightly joined. And in fact, let's look at all the assays. You can see LabKey will give you a view of the assays that were run on this blood sample. And that's what you're seeing right here. 3 assays were run on that blood sample: CBC, chemistry, and nutrients. And those are the results. And also, samples support this cool thing called a timeline. It gives you a whole history of the sample. So I registered it, or Hannah registered it back in April. She updated it. She did a bunch of assays on it. I checked it out. I updated it. Yada, yada, yada. It goes on and on. So it's really just to give you a sense of some UI that's beyond LabKey Server, is really sophisticated and purpose-built UI. And it's a whole application that's just focusing on samples and their management. So this is available to you if you want it. Is there anything I want to make sure I hit? That's good enough. By the way, just to remind you, we're still inside of LabKey Server. Let's just go back. Sure enough, We're just here. And the blood vial, the blood table is all the same. It's still the same blood table. I can still search it and find that blood vial 1500. There it is. LabKey Server has its own views of this vial. They're not quite as cool, but they're still cool. Like, interestingly, look at this. This is how LabKey handles the relationships. It's really a lot of relationships. There's this DNA and PBMC graph here that tells you all those relationships. But if you wanted to see like this thing, here's that lab and that study and that subject, and they contribute to blood 1500 and blood. Yeah. Slightly not as slick, but it's still there. Those graphs are still there in another form. Actually, let's do. There you go. This is pretty close to that view we looked at inside of Sample Manager. Anyway, so that's all I wanted to say about samples. Just wanted to touch on them. And let's take a break. Let's take a little 5-minute break. And I'll be back at like 10:17. Questions? Also, feel free to throw in some questions as we go. All right, thank you. I'll be back in 5. All right, let's get back into it. Welcome back, everybody. Let's move on to kind of the second main course of the day, the data structures unit. LabKey stores data in 2 ways: as files and as tables in a database. We kind of looked at a little bit at each of these, but I wanted to kind of circle back and look at these a little more systematically. The files are surfaced to people through a web UI, through that file repository window, kind of that Dropbox window. We've been playing with it. There's a lot you can do with it. These files do not live in the DB. They are just on the file system. The file's contents are searchable. As soon as you import the file, it becomes indexed, and you can then apply searches to it. So that's kind of files. The DB tables, the database tables, they're probably the 4th time I've said it. They're surfaced to users as data grids in the web UI. That data actually lives in the DB, and it has fulfills and kind of obeys all the DB rules. Like the columns have data types like integer and decimal, and best of all, the data in a database is dynamically selectable, aka you can write SQL queries against it. And we'll look at that this unit. The file repository itself, I don't want to spend too much time on it, but just to give you a little bit of more detail on it, you can define this locally, like on the machine that LabKey is stored on, or you can also do it in the cloud. Like you can put all your files in like an S3 bucket and tell LabKey to put them over there. Again, it's full search. Also, file tagging is supported. So on import, you can actually have LabKey ask for different tags on that file. So that can be really kind of like layering it with metadata. You can do things like have email notification, sort of more like a filled out Dropbox kind of a functionality. And you can control access to the files using the same mechanism that we talked about yesterday, like assigning roles to people in folders. The UI looks like this. We've sort of looked at that. Databases. This is the mainstay of the unit. I want to talk more deeply about databases and the data grids that surface them. Tables are all over LabKey. We played with a lot of them. They're not all created equal. There's 5 table types in LabKey. lists. We've seen those a bit. Data sets, those for tomorrow. Assay designs, we just played with one. Sample types, we just played with one briefly. And data classes. Those are the 5 big table types. They all have universal properties, they all share, but they all have superpowers. Each one has its own superpower. The superpower of lists is just being generic and flexible. The superpower of data sets, they're designed to track organisms over time. So there's a time component built into data sets and an organism component. They're sort of built into data sets. Assay designs, their superpower is, well, there's many superpowers, but I think we've seen some of them, but I think it's more that it has a whole bunch of superpowers around parsing experiment files, having QC states built in, having experiment parameters built in, stuff like that. Having file provenance built in with links to the files, things like that. Fourth, the superpower of sample types is they support relationships. We saw those relationships in that graph where it's like the samples are linked to different sources and different derivatives, like the blood derived into PBMC and those derived into DNA. And then data classes are actually a lot like sample types. They're for, we'll say they're for general metadata capture, and their superpower is that they also support relationships or lineage or parentage, however you want to call it. This is the most important slide of the training right here. Like, you can just keep coming back to it. There's a lot to this. And because, why is it so important? It's because knowing where to put your data is kind of everything. And you'll make the most of your data by putting it in the right spot. I mean, notice I've already learned that lesson in some detail. With that cell culture data, we put it in a list and we got a lot done with it, but it was much richer to put that same data in an assay design. We got a QC workflow out of it. We got experimental parameters and grouping out of it, etc. We got file provenance out of it. You can't do that with a list. Some of the things that are universal to all these tables. You can filter them all, you can sort them all, you can make custom views on them all. You can do column labeling, conditional formatting, range and regex validation. What's range validation? Again, that's where you can set a boundary for values. You can say, I only want to accept values here that are between 1 and 100. And if they go outside that range, I want to error out. Regex validation is similar. It's where you do text validation. You can say, like, I only want to accept emails here. And if it doesn't look like an email, I'll reject it. You can obviously add and remove columns for display. You can do visualizations and statistics and lookups and stuff like that. Oh, and also export. And these are all universal features of the tables. As for designing a table, we've designed 2 tables now. We made a list and we made an assay design. And basically all of those design experiences have something in common. All tables have a global set of table properties and then a set of fields. That's it. And that's what you're seeing here. Here's that assay design again, the table design. These are the global properties of the assay. These are the runs. These are the fields. There's results, runs, and batch fields, but so that's basically table design. One thing I did want to emphasize here, though, is remember how rich the field designs are? Like, if you open up an individual field, notice how rich this stuff is. There's a bunch of stuff here. You should play with all this. notice there's even an advanced tab here, advanced button. So you can do things like control whether this field shows in the grid or whether it shows on insert and whatnot. There's a whole bunch of stuff here. I think I will skip this demo because I think we've already done this twice. But again, basically, if you want to design a table and capture data, what you do is you look at your Excel file, you decide you got to decide where it goes. Does it go in a list? Does it go in an assay? Does it go in a data set? If you don't know where it goes, put it in a list. And then build the file, build the fields, give them the properties, and then import the data. So let's take a look at data grids and kind of look at their underlying architecture. We know that they come from the database, great, but it's actually this more complicated than that. There's actually a whole bunch of stages that the database goes through by the time it gets into the web browser as a data grid. And there's even a bunch of, you can control that flow really quite subtly with there's a lot of places where you can intervene on that flow out of the database. And I want you to know about this. This is like the second most important thing in the training. So here's the basic view of it. You have tables in a database. Those enter the server as queries. And those queries are displayed in the browser as grids. Now, you actually have a lot of control right here at the query level. And we've seen you have a lot of control right at the grid level. So these are already two really important intervention points in this flow of database tables to browser grids. And I really want to spend, and essentially kind of the rest of the next 20 minutes, so we sort of really digging into this, how you can control that stuff. Now, first of all, let's take a look at the queries. Like, okay, what are these queries? Well, there's a place on the server where you can see all the queries. And it's called the query browser. And let's go, by the way, I did a presentation on this back in October for the user conference that is now on YouTube. You should go watch that. There'll be more detail on that, on what the query browser is, what queries are, like what's the whole point. But this is my quick version. Let's go look at the query browser. And let's go to our main project. And you go to the query browser by going to Gear Modules Query. Or let's navigate away. That's the query browser. You can also, if you're really cool, what you'll do is you'll just take the module name and turn it into query. You can come back to the same place. Here's the query browser. What is the query browser showing you? It's showing you all of the tables in the database that LabKey knows about. It's showing you, to put that another way, it's showing you everything, every table that LabKey can see. And when it sees a table, it turns it into a query. And so that's what you're seeing here. The tables themselves are put into groupings called schemas. And that's what these folders are. So there's an assay group, an assay schema. And when I open this, I'll see all these tables inside. There's an assay list. What's the assay list? It's a table. It's a system table. What do you think it is? Well, lo and behold, it's the cell culture assay and the pH assay. What else is there? There's this general thing. What's this? There's this cell culture assay. Well, lo and behold, there's 4 tables in here. There's a runs table. What's the runs table? Lo and behold, it's that guy. It's my cell culture run fields. Media type, incubator ID, QC flags. Oh, well, there's also this data field. This should probably be called results. What's on this table? Oh, it's just the cell culture results. So I hope you're getting a sense here that the query browser contains all the data that we already know about and more, and a bunch of system tables as well, which are really important. Now, you actually have control here over these. Oh, here's another thing: QC flags. What's this? Oh, it's a table of the QC states I put everything in. In any case, so I hope you're getting a sense that the query browser contains all of the user tables that you define, and then a bunch of system tables. And you can actually control these tables as well. You can control how they're displayed. You can build all kinds of stuff around them to help out your applications. And that's what I want to look at next. So let's get into sort of that's kind of the basics of data structures. There's 5 of them, and there's a query browser, which you can use to surf around. Let's get into some more advanced topics now. First of all, here's the real view of how tables turn into grids and beyond in LabKey. There's all kinds of layers. And let me just kind of take you through the history of it. Okay, all things start with tables in a database. Like then LabKey comes along and says, oh my gosh, there's tables there. I'm going to make a bunch of queries. And it does that. So we've already done that. And you can see those queries in the query browser. Now, next, if you want to, you can build your own SQL queries on top of those. And I'll show you that in a minute. We'll call those that's the custom queries level. That's like another level of evolution. And if you want to even make more changes and more sort of morphing of the data, you can add properties called metadata properties or query metadata on top of those. These are properties that are defined in XML, and they kind of wrap the queries. And they can control things like display and all kinds of stuff. Now, those in turn into data grids. These are the data grids that you see in the browser. Like this, now we're at the browser level here. All these 3 are now browsers. And then grids, you can create different versions of grids and save them, and they're called views. And then finally, the final thing that you can create are reports. And I don't mean just visualization reports. I mean, a grid itself can be a report. A report is defined as, I define a report as the final consumable by an audience. Like the audiences come to LabKey to see reports. And so that's kind of the final presentation. So that's kind of the whole history, or the whole sort of flow from databases to the final consumable. And you can take advantage of, if you know what you're doing, you can use any or all of these intervention points in the flow to control stuff. Now that's a lot. I want to pause. See if there's any questions here. Yeah, we've got, are these sessions recorded, and where do I find those and training material? They are recorded. We're going to send them out next week. And you'll just get the email because you registered. You'll get the links because you registered. So that'll just happen for you. And I'll send you some other training materials as well, like tutorials, and check out the YouTube channel. There's a bunch of stuff on that. Another question: what is the visibility of custom grids? Do I only see the ones that I defined? And the answer is no. You can choose, when you make a custom grid, you can decide to share it with everybody else or not. You can do either. And actually, it's worth just doing that. So we're working right here at the views custom grid is also the same as views. Let's make a custom grid. I don't even know if we've done it yet. Let's do it through the query browser. I'm going to go to the results for my assay. And let's say I want to filter out all the rejected stuff. I want to make a special view that doesn't show the rejected stuff. I'm going to filter it. And I'm going to say, I just want to see stuff that's passed. The rejected is going to mess up my results. I don't want it. So now I've filtered it. Now I'm going to save this as a custom grid. And I can do that. But it's inviting me to. It says save. It says this grid has been modified. Do you want to save it? Yeah. Now, this is kind of a complex little dialogue here. Do I want to save it as the default grid? No, I just want to name it. I want to save it as a named grid. And I'm going to call it the past QC grid. So it's going to have two versions of the grid here. And now I can say I can either make this grid view available to all users, and I'm going to say yes. So this is me sharing it with all users. And great. Now, if I navigate away, let's just navigate away. I can now go and see this past QC version of it. And it screwed up for some reason. Why do I see rejected there? I did something wrong. But that's what it's supposed to be like. Here, let's go. Let's go back to our query browser. And did it work there? Okay, I'm seeing that. And I'm looking at past QC. I did something wrong, but that's the idea. It's supposed to work that way. I'll keep moving here. Next question, where does the QC flag variable and values appear in the assay design? It's actually you kind of have to put it together yourself. To make it all that QC stuff, you have to turn it on. First of all, you go to the designer and there's a little like check mark. Say turn on QC states. Then you have to define the QC states. And then you actually have to sort of incorporate it into the grid. It doesn't just all happen automatically. You sort of have to sort of work with it. So, I mean, now I'm kind of pissed off. I want to make this work. So here, let's go back to my default view. Let's customize this grid. Let's add this run. Let's add the QC flag. So you got to sort of do all this. There, I'm adding my QC flag. I'm going to save this. And I want it to be the default view, and I want it to be visible by everybody. Great. Now, let's go back to the past QC thing. Let's customize this grid. See, I didn't get that filter to save right. Let's do this again. Let's filter this. Let's say I just want to see past. Let's save this. Yes, I want it to be past QC. Okay, let's try this again. Now let's navigate away and try to get ourselves back there. Okay, there's the default view. It shows the rejected. Let's go to the grid view I just created. Great, okay, that's what I wanted. Super, I've got a way to do it now. So I hope that answers your question. You kind of have to, a lot of these features, you sort of have to do some work to make them really work well. And that QC flags are definitely one of those kind of features. So let's kind of go through some really cool things you can do with data, with tables. We already did one. We saw grid views. Lookups. This is one of the great features of LabKey is the ability to make links between different tables. And we saw this, it's called a lookup field. And we saw this, it's a good demo of this over here. If you take a look at this demographics table. Here's a table of people in my study, and it has a bunch of metadata about them. One of the things that we record is the language they speak. And there's what this column does, this languages column, is it actually looks up to another table called the languages table. And that's right here. And the languages table has like a translator for that language and a phone number for that language. And so you can sort of create these, now when you make a link between demographics and language, you can make quick joins of the data. You can now have these hybrid views of the data and put two tables in one grid. That's what I've done here. There's the translator name. There's the phone number as part of the demographics table. And that's just a technique you can use over and over again. The way it looks like in the designer is this. This is a list. Here's the fields. And here's the language field. It's a lookup. And let's open up the details. It's a lookup that goes to the list languages table. And I could look it up. I could make a lookup somewhere else if I wanted, but in any case, that's how that. So lookups, really key, really great feature. And I will skip I did the demo essentially there. System queries. There are many useful queries or tables that LabKey creates without your intervention that you can use. And I just want to point them out. It's worth going through the query browser and just kind of shopping around. There's a bunch of cool stuff like files, containers, and users. Let's go take a look at these tables. I'm going to go to our main project and let's go to the query browser. And there's a bunch of this EXP schema is really interesting. It has all kinds of stuff in it. These are all system fields, all system tables. But one of the most interesting ones is this one called files. What is this table? Well, lo and behold, it's a tableization of our files. And it's like, let's just remind ourselves, what files do we have? They're over here. There's culture 1, there's cell culture 001, participants, and then there's this folder assay data with a bunch of other stuff in it. Well, this table is just how LabKey handles all the metadata about those files. It's like how it stores it all. And so it's like all the same stuff. There's cell culture 1 and participants and whatnot. But it also has this metadata, like it has the file size and whether the file actually exists currently, and it gives you a download link and a link to the assay results that have been imported. It's a really nice little, essentially an alternative UI to the file window. So, I mean, I figured you can use that table. You can go and utilize it. So I'm going to go and just stick it on here as kind of another UI. You can do that by using the query web part. So I'm going to use the query. The query web part is how you display any table. And I know this is a system table inside the EXP schema. And we want to show files. And lo and behold, I have now kind of 2 ways to interact with my files. Kind of cool. And, you know, you can also do like sort stuff. Like if you just wanted to, you can filter this, you know, like if you say, I just want to see, you know, files that are just Excel files. You can do that too. So now I just have a table that just shows the Excel files. Things like that. That's a really great little thing. Don't neglect that. And then there's some other really nice tables that you can use, like there's this containers table in core. It's like core containers, we've seen this a little bit. This will give you a tableization of all of the folders on the server. This can be really handy for admins. And it's an alternative way to navigate the server. It gives you all kinds of possibilities. And then finally, I just wanted to point out there's this users table. This is a table of all of the people that have accounts on the site. And it gives you like their email and their display name and their phone number if they give it to you and all that kind of stuff. So anyways, that's nice to know about. And there's a lot when we get to studies tomorrow, there's all kinds of system queries that are clustered around studies, which are super useful, and you can really build reports on top of them that are meaningful. Custom queries. You can build custom queries in LabKey. You do it in a language called LabKey SQL. That's what my presentation is about from October. Definitely go watch it. But let's just remind ourselves that you can do custom queries here. And let's build one. Let's build a custom query on our assay, just to kind of keep working with the same data and evolving the same data. Let's go to our results table. And let's say I don't know, I'm just going to let's build a query on it. The way you build a query is first of all, you select the table that you want to make as your starting point. And then you say create new query. There's a button here, create new query. That'll put me into the SQL editor. And first I have to give it a name. Let's call it let's say this is a query that's looking for high cell viability. And there's my first, it'll give you a SQL query to start with. And you can run it. Now this is like a SQL designer, this little UI. You can run this by clicking execute query. What does it do? Well, that's the results of this query, but that's just a very generic query. It doesn't really do much. Let's filter for high cell variability. And let's say that I'm going to put a where clause on this. This is where it filters. I'm going to say where viable cells percent is greater than 90. I hope that works. Great. There's a meaningful query. It returned 2 rows. See, let's kind of lighten it. Let's say it's like 80. Oops. Great. Let's say that's a query I like. It's meaningful to me. Let's save it. Now I'm going to save it. And now this becomes another asset that I can surface on my data. And you can surface it with the good old query browser, with the query web part. But first of all, let's go back to the query browser briefly. There you can see it's part of the query browser now. And there's a new query in town called high cell viability. I wrote it. It's my piece of SQL. And you can see that it's linked. This down here at the very bottom, there's something called the dependency report. It shows you the links between your queries and the system queries. And so what it's telling me here is your query high cell viability is based on the data table, the results table of that assay. That's what that is right here. And it goes the other way too. If I go back to the data table, this is the system query, the results table for that assay. And I scroll all the way down, there's a dependency report and it says, hey, there's a query built on top of this. And it's called high cell viability right here. Now, high cell viability is just sort of in the basement right now. No one can see it. I'm going to go surface it. I'm going to surface it on my assay dashboard, which I'm building out. And I'm going to add a query web part. And I know it's part of that schema, the cell culture assay schema, and it's right there, high cell viability. Now I'm surfacing that query. Great. Now that's the most boring SQL you've ever seen. You can do a lot more with it. I think a natural piece of SQL would be to ask something like this. Which media provides the highest cell viability? You could answer that in SQL. I can't do it off the top of my head, but it would be a great question to ask and build into a SQL query. So I think a cool thing would, if a smarter person would do it, build that SQL query, then you have the table, and then you could build a visualization of that on top of that query. That's a really common pattern in LabKey, is to start with a base table, build a query, and then build a visualization on top of the query. See that over and over again. That's a classic pattern. So anyways, that's queries. So much you can do there. Watch my October presentation. Query metadata. These are properties that you can layer onto queries. And actually, let's go back a little bit to this graphic to kind of orient ourselves. We're right here. We've actually done this a whole bunch of stages of this evolution. We had tables in a database. We did that when we defined our assay. Those turned into queries. We didn't have to do anything. That just happens. We just built our first custom query. It's called high cell viability. And now I'm going to layer some more stuff on it. I'm going to layer some metadata on it to kind of change the way it's displayed. So let's metadata. Let's go to that query, high cell viability. By the way, I'm doing some kind of fancier navigation through here. Notice I can click the title of this web part, high cell viability, and there's actually a little breadcrumb trail into the schema browser here. Right here, I can just click this and I can kind of go into the schema browser, right where I want to be. Notice there's an edit metadata button on this query. Let's go over there. What's that look like? Well, lo and behold, it's like this field editor. And it's a way to control the query metadata area is a way to control system tables and really any table, much like the field editor. So I can do things like this, like if this viable cell percent, maybe I want to make that kind of have a better label. Like maybe I want to use the percent sign. So that is my first little bit of query metadata. And if I view my grid now, I can see I changed the label in that column header. That's a really simple way to do it. You can do this for system tables as well. Like you have control over that stuff. Another thing we might want to do is the pH have a good label here? Yeah, it already does. And what's some other stuff you can do? Well, you could also do something like this percent. If I wanted to put a kind of some color coding on it, I could do that as well. There's this conditional formatting area. And I could say, if the value is greater than or equal to 90, I want something to happen. I want the fill color to be kind of this red, this orange. We'll make it even this red. It's too bright, but we'll do that orange, that red. And now when I save this and look at my data, now it looks really, it's kind of a little bit indicative. It's sort of saying something like, oh, these are really high values. So those are kind of some of the things you can do with query metadata. And if you're willing to work in XML, you can even go further. And so what that editor does, this editor, is actually writing XML in the background. And you can see that XML if you go to edit source. You can see this is what we just wrote. There we put that percent on the title, on the label, and we put this like filter, this conditional formatting on here. Well, if you want, there's a whole bunch of XML that you can write out that's not supported by the UI. And you can get that right here. There's a help menu here. This will tell you, this will give you a reference to the XML. And so you can do things like really all kinds of stuff, like all kinds of stuff. I'll spare you the. In any case, so just some advanced features to keep in mind. And linked schemas. Linked schemas are one of the great techniques for security in LabKey and for generally refining data displays in LabKey. And let's do this. I'm gonna, what they do is a linked schema allows you to take data from one folder and represent it in another folder. But you can do it in a very refined way. You can say, I just want to take, if say your folder A has everything in it, including sensitive data. And you want to just take a sliver of that data, the non-sensitive sliver, and show it in folder B. That's what a linked schema can do, is it can make that link between A and B and show whatever data you want. And we'll say in this case, sort of non-sensitive data. So we can do that. Let's go to subfolder A. Remember that we actually have a subfolder of our main project. And let's make a linked schema from subfolder A to the main project. And let's pull in some data that we want to show. I'm going to go to the query browser. I'm in subfolder A. This is where we're going to move the data to, or re-show the folder to, re-show the data in. Go to the query browser, and I'm going to go to this schema administration area. And there's a linked schema option here. I'm going to go into the linked schema thing, and I'm going to say, what I'm saying here is I want to pull in some data from another folder. And I need to characterize that data. I need to give it a name. I need to give it a schema name. And I'll call it, data to show. Now I need to pick the folder the data is coming from. That's the source container. Where's this data you want to show? Where is it? Here it is. It's in what do we call it? Main folder. Look at it. I can shop every folder on the site. Can I do type ahead? Sure. I can do main project. Now I can, there's some other stuff here, but let's ignore that. Which schema does it come from? I'm going to say it comes from the cell culture assay. And now I can pick any of the queries that are system or self-defined or user-defined. Well, lo and behold, there's my high cell viability. I'll show that query. And it's the only query it's the only data that's going to be available in this folder. Like, it's a restrictive idea. Like, let's suppose this is, I just don't want to show the other stuff. This is the only thing I want to show, is that high cell viability thing. So let's say that. And there's even a place to put metadata here, but we'll skip that. Great. I just did it. It's now this, I just made some data from the main folder available in this folder, subfolder A. What does it look like? Well, let's go to the query browser again. Oh, it's right here. Sorry, there's another way to get to the query browser. It's right here. Notice there's a new schema in town, data to show. And if I open this, lo and behold, there's one table in it called high cell viability. Let's look at that. Well, there it is. It's my little sliver of data from my assay. I cannot see anything else from that assay here. And so this is one of those great techniques for highly controlled data presentation that you can use in LabKey. And this is essentially row-level security for LabKey and column-level security. You have full control over what you want to show using this kind of technique. And I consider this now, I'm paying off on my promise I made back in October to really show in detail what I was talking about. This is, again, just a technique administrators should really learn, because you can just do so much with it. So again, the technique is make some views of the data that you want to show, create a linked schema somewhere else, and show those queries. That's it. That's all I just did. Oh, and then do independent security on that folder. Right now, we haven't really done the security part, but imagine that I'm only going to let a few people in to see this query now. I'm going to hide the source project and everything. All right, so that's linked schemas. And this is another thing. This actually goes back to a question we got yesterday about, what if I've got databases with pre-existing data? Can I show those in LabKey? And the answer is yes. And you do that with something called an external schema. And we support Oracle, Postgres, Microsoft SQL Server, MySQL, SAS, and maybe Redshift. And basically what you do is you just tell LabKey about these other databases. Databases have a little URL you can use. You tell LabKey about that URL and you get the data. So how do you do it is you go to the schema browser, query browser, you go to schema administration, and there's an area here for external schemas. Now, I don't really have a way to do this demo fully, but I'll kind of show you how it works. You go and you create a new external schema. You sort of give it a name, and it'll be like, my, whatever it is, my Oracle DB. And then this dropdown will be populated with that Oracle DB name. And then you can pick which tables you want to show and show them. Now, there's help docs on this. And by the way, this is also little known. If you want the help docs for external schemas, what you can do is go to the external schemas area, or whatever feature you're trying to get docs on, go there. And then if you go to the Head and Shoulders icon and click LabKey documentation, well, lo and behold, you'll get the docs on external schemas. And so what you're going to do to really make this work is, actually, the first thing you got to do is do something in Tomcat. And so if you're, if you want to say attach to an Oracle database, you would go to Tomcat and use this little snippet inside of Tomcat. You're going to add that snippet to Tomcat, and there's the database URL right there. This is what LabKey really needs, is that database URL. And once it has that, it can attach to Oracle, pull data from it, and then you can pull it into LabKey. And you're essentially, when you do that, then you have full control over the data. You're essentially, you put basically a new database under it. LabKey will suck the queries in. Now you can do custom queries and grids and views and reports and do whatever you want. I wish I had a better demo for it, but I just can only kind of talk around it. That was kind of all I wanted to do today, really. There's kind of plenty. I'm sure that was a lot. And tomorrow we're going to look at studies and reports. So we're going to sort of complete this path by topping it off with reports. And also we're going to add a new data type into it. We're going to add the data sets. And data sets are really cool because they're very climactic. Data sets can suck in assays and samples and all that. And they're kind of integration hub of LabKey. So we're kind of all that data is going to converge tomorrow in a study. We're going to write reports on it. It's going to be very climactic. Questions for stuff we did today? Anything, even stuff we did yesterday? Well, if you get inspired, write down your questions tonight, and we'll do them tomorrow. Give people a few seconds here to think of a question. Oh, you know what? I do have, Natalie, you still had a question about where would I look for assay stuff? I mean, sorry, where would I look for participant and sample records in the audit log? We might as well go do that. Let's go do it. I'm going to go to this sample manager. Let's go to that sample manager we looked at before. It has an audit log. And let's look at the audit log. For this guy, make this screen a little bit bigger. First thing I would try is there's a sample timeline event. There's a couple of sample tables. Sample timeline event will tell you that the sample was, like, these are all samples updated, blah, 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 blah. This is one of those, if you want to get more details, again, add those old value, new value columns. Now I can really get a detailed sense of, well, what does updated mean? Oh, well, it means all this stuff. So I look there, there's sample timeline events, there's sample type events. Now I think this is mostly about changing designs. So I don't know if that's super important for the data itself. And then there's sample workflow events. That's a little bit different. As for participants, what you're going to look at, we'll do this tomorrow, is there's a data set events. And this is not a study, so let's go to a study to see that. If you wanted to see participant events, here I'm in a study folder. We'll do this tomorrow. Let's go to the audit log here. Sure enough, there's a data set events here. And this will tell you everything that happened to your participants, whatnot. All right, anything else out there? Yeah, we got one. Great content, thanks. You're welcome, it's my pleasure. I've really been enjoying this series, and it's just great to, I'm always so awed by LabKey, honestly. All right, well, thanks a lot, folks. Let you out early, and I'll see you tomorrow.